Hello guys, welcome to this new video on machine learning, and this video is about a model which Facebook has recently released, that is segment anything model. So I was just going through the GitHub repository and the demo of this model, and I was very amazed how accurately this model can actually take in images, and it can actually create mask of that mask on the objects that are there in the image with a very good accuracy. So what does it say? So the segment anything model produces high quality object mask from input prompts such as points and boxes, and it can be used to generate masks for all objects in the image. It has been trained on a data set of 11 million images and 1.1 billion masks, and has a strong zero shot performance on variety of segmentation tasks. So this is the description that they have given on the model, and this is the requirement that you will require if you want to run the model or locally. So you can just run this command. Before that, I would suggest you to create a virtual environment and then get started. And after that, you just need to download the model checkpoint. This is a PyTorch based model. So if you just click on here, you will see that they have provided three models here. That is WIT H SAM model, WIT L SAM model, WIT B SAM model. So you should download the default one, and once that is done, then you can use the script that they have given and run it locally. So personally, I feel that I would prefer to run the same thing on Colab and check out like how it works. Before that, let's go through the demo and see how it works. So this is their site, I think. Yes, I have read the terms and condition. Okay, so they have given us pretty good images. So let us try with some images here. Let's try to take this image. Okay, so it is extracting the embedding out of the image right now. Okay, area plus minus sounds good. Oh, you can see this. It is able to mask out the frog so easily. And let's try to do the same with the uh, tortoise here. Yeah, it is able to do that too. Now let's try to take the tortoise as well as the frog as well as the reflection of both of them, and it has been able to do the masking of that. And you see the accuracy also. It is like insane accuracy. So just like that, what we can also do is that we can try out on some other image again. So let's try to create a box this time. Draw a box around an object. So I will draw the box around this object. Okay, and it has been able to get me all the embeddings that are there inside this box. So pretty cool, right? It is so accurately identifying the objects in the image, and I am very much pretty much amazed like how this thing works. Obviously, this is the data set. Let's check the data set that they have given. So they have a full data set of 11 million. So this is the preview of the data set that SAM model actually used. You see the segmentations are so good, and therefore the accuracy of the images also, which we tried to use in the demo, it was able to segment so well. Besides that, if you want to just check out the paper, so you can just go to the site again, and here you have the paper on which SAM actually works. So so you can just download the paper here. So everything about the internal working of SAM has been described in the paper. Personally, reading paper is a tedious task, but still, if you want to know how the model works in brief, you should definitely check out the paper. This is the main architecture of SAM. Like, it takes the input image, it has an image encoder which does the image embedding, and then besides that, it takes the prompt input as points or box or text, and then it spits out three masks along with the score, and out of those three masks, you can choose any of them. So this is the major workflow of SAM. So now, without wasting more time, let's check out how you can run SAM on your custom images through code. And I will not be running it locally. I'll be using Google Colab for it. So I have The code for this you can find it on the SAM repo itself. So if you go to your SAM repo, you can see scripts here, notebooks here. So here you will see some examples that they have provided, and you can just run them through Google Colab. So let me open my Google Colab quickly. Okay, so since I'm using Colab, I'll be making this using Colab True and be connecting it to GPU. So notebook settings have been changed to GPU. Let it connect. So once that is connected, so now let's go to the code of how you can use SAM model in Colab. So firstly, since I'm working on Colab, so I'll just do this. They have just done the using Colab flag as true. Then there are the dependencies which is required for SAM to run. So obviously it works on Torch, PyTorch. So we are importing PyTorch here, PyTorch Vision. Then it checks for CUDA is available or not. Besides that, once CUDA is available, then you need Matplotlib to play around with images. Then we have the installation of the SAM anything model from their GitHub. Besides that, we just make a image repository. Sorry. Besides that, we make a image folder, and inside the image folder, we just randomly store some images. And this is the main PyTorch model, which is available on their GitHub page. This is SAMWit H. So let's run this and get all the things which is required for SAM to work properly. So we have the PyTorch installed, the CUDA is available. Now we have built in successful. Okay, the dog image is downloaded. Now it is downloading the PyTorch. See you see this .pt here. That means it's a PyTorch file. So that is saved. Now if you just open your drive, you see the model is saved here, and you got one more folder called as images, uh, which has a dog image here. So that's it. Then there are some dependencies. We import some functions which is required to play around with the images. So the by default image that it downloaded was the dog image. So we'll try to do the segmentation using SAM on this dog image only. So if you see this dog, it is located here, right, in the left side bottom part. So what we can do is that we can mark this dog, and then we can try to segment it. Before marking it, we should import the model, right? So from SAM anything, we are importing these two functions, SAM model registry and SAM predictor. Then we provide the path of the weights, then the model type, the device is CUDA. Then from SAM model registry, the model type is passed and the checkpoint is passed. And then SAM to device, since it's a PyTorch model. And then SAM predictor, SAM, and the predictor object is created. So run this thing. So once it finishes running, then you can pass the predictor, the image to the predictor using the set image method. Now, once you pass that, what if you want to just isolate this thing? So what I can do is that I can pass the pixel value on which I can pass the pixel value of the numpy array which I want to segment. So I want to segment the dog, right? So the dog is at this point. So we can just mark it. So you see this star mark, this is marked for this dog. So now once that is done, we just use the predictor and use the predict method from it. Then we provide the input point, input label, and multi-mask output as false just to keep things simple. So here we have the input point, we have the input label, and we run it. So once that is done, you can see how SAM will produce the result. So you see the segmentation is out and it is so accurate, right? The dog is very, very nicely segmented, and it looks amazing. So this is how it looks. Now let's try to do some segmentation on this bowl itself. So if you see the earlier image, if you see the bowl is located on 600, and if you see this is 200, right? So I'll try to mark 600 comma 200 and try to see like if that changes something. So 600 comma 200. Let's try to see where the marking is now. Okay, so it's on the bowl, right? Oh, so it got the part inside the bowl. So if I want to just shift it a little below, Let's try to do that. So instead of keeping 200, we can keep something around 200 and what is this? 250. So let's keep 250 here. Okay, so you see the bowl is now selected so nicely. So this is how it works. Now let's try to select the lady who is giving food to this dog here. So the lady is on 700 on X and what we can say 200 on Y. So 700 comma 200. So the lady is also masked, and you see the accuracy, right? Insane accuracy. So this is how SAM actually works. In the code part, you can even pass in the bounding box and get the objects out of it, just like you saw in the demo, and you can do the same with code too. So for that, they have provided some examples on the repo which you can check out. So this was all that I wanted to show you in this video about SAM model. I hope that you like this video. I am waiting for more and more updates from Meta AI on the SAM model and see what exciting things they are going to bring in this SAM model in the future. So if this video adds any value to your AI learning journey, please hit the like, share, and subscribe button.